This is exercise 15 in chapter 4 of our textbook, where it says a bowl contains two kinds of identical looking foil wrapped chocolate egg-shaped candies. All but 42 are milk chocolate, all but 35 are dark chocolate. So what we basically have here is a sample space that contains only two kinds of chocolate. Those that are dark, those that are milk chocolate. And notice in my Venn diagram that I've drawn here, I've not intersected those circles because a candy cannot be both milk and dark chocolate. So these are mutually exclusive kinds of candies. Now the way that this information is provided is a little bit tricky. It says all but 42 are milk chocolate and all but 35 are dark chocolate. Since there are no other candies in our sample space and the total number of candies is equal to 77, well, of those 77, all but 42 are milk chocolate, which means 42 must be dark chocolate. And all but 35 are dark chocolate, therefore 35 must be the number of milk chocolate candies. So in A it says how many of each kind are in the bowl. Well, we've just identified dark chocolate is 42 and milk chocolate is 35. In B, how many candies are in their bowl? Well, because those were the only kinds of candies in the bowl, and they added up to 77, then there were a total of 77 candies in the bowl. C, if one chocolate is selected at random, what is the probability that it is milk chocolate? Now, there's no given here, and we've learned about conditional probabilities. This is just the probability of randomly picking a particular kind of candy out of the total. So when we just are finding the probability of a simple event, we want to use this first formula on our formula sheet from chapter 4. We have to take the number of ways that event can occur, and in C we're finding the probability that it's milk chocolate. How many ways can we pick a milk chocolate candy? 35 ways. And then we know that n, little n, always represents the sample size. And so the sample size we identified in part B was 77. So our probability of picking a milk chocolate from this bowl is equal to 35 over 77. In D, if one chocolate is selected at random, what is the probability that it is milk or dark chocolate? Well, we've learned that OR means union. And we have our union formula on our formula sheet for chapter 4 that says to find the probability of M union D, we're going to add the probability of M, which we've just determined is 35 over 77, plus the probability of D, which we've determined then would be 42 out of 77, using the same formula we used in C, minus the probability of M intersect D, which is the same as M and D. So we've got to count the number of ways we can pick both a milk chocolate candy and a dark chocolate candy at the same time. Well, we can't do that because these are mutually exclusive events. So the probability would be 0. And therefore, in answer to D, the probability that we pick a milk or dark chocolate candy is equal to 77 over 77, which is equal to 1. There's a 100% chance that the candy we pick will be either milk or dark chocolate. And then in E, if one chocolate is selected at random, what is the probability that it is milk and dark? We've just identified that that can't be done. That can't be chosen in one pick from the box. So that probability is 0.